In this video, we are going to discuss the conjoint analysis. So, conjoint analysis is a special type of regression analysis, right? Now, first, let's install a new package called Conjoint. And if you already install it, you don't need to install it again. And please load the required package of them here. All right, as usual, we will have some initial data exploration. First, for today, we have two data sets. So if you look at on the screen right now, you will see the first data set, it is about the bundles. We have 9 bundles and we collect the rating data from 20 respondents. All right. And that data set we call conjoint. And for the second data set, that is the attribute information. So we have 4 attributes, life expectancy with 3 level. The second attribute is speed with 3 levels. The aesthetics with 2 levels and the price attribute with 3 levels, right? Now, let's open the conjoint dataset. And second, let's open the attribute dataset, which is profile. Great. Please make sure that you reload to required dataset properly. Now we can check the column names of each dataset. So for the DF dataset, we have 9 bundles. Is correct. We have the first columns right here. It seems like unnecessary that we are going to remove very soon. And let's check the column names of the profile dataset. So for the profile dataset, we have 4 attributes. Okay, and again, the first column is not necessary. The next step, we can check some basic summary statistics. Okay, let's do it with the DF dataset first. So if we look at this summary, we can see the scale for each bundle is on 0 to 100 scale. So basically the company already collected the rating data from the customer on a scale 0 to 100. Now let's summarize the profile dataset. So in the profile dataset, we have 4 bundles, right? Life expectancy, speed, aesthetics, and price. And we can have the final look at each dataset. Now let's view DF. So the DF will look like this one, right? We have 9 bundles. And the rating for each bundle from customer on a scale 0 to 100. Now we can view the profile dataset. So we have 4 attributes again. Great. And to be able to run the conjoint analysis, we need to clean the data. We need to pre-process the data a little bit. Okay. As in the initial step, when we explore the data, we know that in the DF dataset, we have the first column correspondence rating, which is the row order. And we already have it in R, so we don't need this column, right? So we just remove the first column by specifying -1, right? And we can check the column names of the DF dataset again. Now, this look neat. We have bundle 1, bundle 2, until bundle 9 columns. All right, so remember, on the screen right now, I show you the basics of conjoint analysis. So it is a special type of regression analysis. And for dependent variable, it is already the rating from the customer, so it is continuous. But for all the independent variables, we need categorical variables with factor levels. Okay, we need to input the levels of each categorical variable into the regression analysis. And in this case, the dependent variable is the bundle rating from the customer. And we have four attributes: life expectancy, speed, aesthetics, and price. We need the levels from each of these attributes. Having said that, we need to check if these attributes are already in categorical format or factor or not. So we can check using the function called is.factor. So let's run the code for the column life expectancy first. Right? And we see the computer answer false. It means the current nature of the column is not categorical. Okay, we can do the same for the second column, which is speed, right? And we can specify speed here and run the code. And again, the computer say false. The column is not categorical. Let's check the aesthetics. Also false. Now check the last attribute, which is price. Also false. So all of these attributes are not categorical. And then we need to transform the attributes into factor variables by using the function called as.factor. So again, right here, we only need to convert those columns into factors and save the result in new variables. Okay, so right here, I will convert the life expectancy column. Let's call it life expect, right? And save it in the new variables. Let's do the same for speed and save it in a new variable called speed. And let's do the same for aesthetic. And do the same for price as well. Right. So we just transform all the attributes to categorical or factor variables. Now we can confirm again if we are successful with the change or not by using again the is.factor function. Now the computer says true. So it means that the variable, the attributes, has been converted successfully. And let's do the same for speed. True. Aesthetics. True. Priced. True. Now we are safe with the control analysis. But before we run the control analysis, we need to create a new data set with these factor variables. So basically, we just create a new data frame and we store all these four variables we just created above. The first variable is life expectancy. The second variable is speed. The next variable is aesthetics. And the last variable is price. Great. And let's view the new data frame. This looks nice and neat, right? And one more thing I always suggest you to do is it's very important to make sure that the order of these new data sets follow the original order of the data. What is the reason for this? Because when a customer rate each bundle, they will read the characteristic of each bundle. Basically, they read all the attributes. They just don't evaluate each attribute separately. And we need to keep that original order for our data set, no matter what we are doing with the data. For instance, like cleaning, arranging the columns, but always try to make sure that we need to keep that original order on the attributes as how customers saw it in the survey. Great. And in this case, now the order is exactly the same as customers saw all of the attributes in the survey. All right, so again, we already have the bundle level data. We have the attribute level data. Now, another type of data that we need, like on the screen right now, you see, is the attribute level data. So basically, we want a column that store all the attribute levels, all the levels in one columns, like this one. Okay, like for instance, life expectancy have 3 levels. We store those 3 levels, and next speed have 3 levels, and next aesthetics we have 2 levels, and price we have 3 levels. All of those will be stored in the same columns. How to do that? Basically, right here, we need to create a new column, right? And could you please fill in the blank for the missing levels? So you can see the first 3 levels here belong to life expectancies, right? Now, what are missing levels? Basically, the missing levels belong to speed, right? So if you forget what are the levels of speed, you always can check back the profile dataset. So for speed, you have 3 levels, 1.0, 1.2, and 1.5. So we can type it here. Great. Do you see any difference, any weird here? The color, right? If we type the number like this, the computer will understand the value we just key in are numbers, not characters. So we need the quotation, right? Great. Now, let's run this live code, okay? And right here, you see, this is the column at attribute level. And we need this column for further analysis. Great. So we just prepare the data, we just clean the data a little bit, and now we are ready to move on to the conjoint analysis for each respondent. So again, as I mentioned in the lecture, for conjoint analysis, you can run the analysis for each single respondent. And at the same time, you also can run the analysis for all the respondents. Right. Now let's start with the conjoint analysis for the first respondents. Right here, we need to use a new function called CA model. Please question mark the function. And please read the instruction right here. And make sure you read it and understand how to fill in the blanks right here, right? So to use this model, we need y and x. What is y? Y is the vector of preferences and should be like a single profile of preferences. What does it mean? Basically, right here, we need the rating from the first respondents, right? And that data come from TF dataset. And in particular, we need the first row of the TF dataset. We need the rating from the first customer for all 9 bundles, right? And right here, we can specify the first row of TF, right? Right. What is X? X basically the profiles of all the attributes. And we have that data set called profile. So let's run it. Great. So right here you see the result, the model result for the first respondents, right? In particular, for the first respondents, the first level of speed is quite important to them. And that could be different for the other respondents. Right. So right here, you only see the model result, the regression model results for the first respondents. But just in case you want to see the utility score, for all the attribute level for the first respondents, we need to use a new function called CA utilities. Okay, you can question mark the function one more time and make sure that you read the instructions right here. And to use this function, we need X, Y, and Z. What is Y? Y is the matrix of preferences. So basically, again, we need the rating data from the first customer. That is DF, first row, right? And of course, we need the profile of all the attributes stored in profile data. And what is that? Remember, we just created attribute level data, the column storing all the levels. And we call that column is attribute level, right? Great. So let's run the code, okay? The code not only give you the utility score, but also give you a lot of useful plots, okay? So right here, you see the utility score of the first attribute, which is life expectancy. Low, medium, high, right? And right here, you have the utility score for speed, the second attribute, 1.0, 1.2, 1.5. And right here, you have the utility score for the first respondent for the price attribute 8, 9, and 10. And we have the utility score for the attributes of aesthetics with no imperfection and minor imperfections. Because for the first respondent, only the first level of the speed is significant at 0.1 level, so we can justify only the speed, right? What does it mean, the significant level right here? So for the first respondents, they really care about the speed of the product. And in particular, the speed 1.0 is more important than the other level of speed. That's it, right? All right. And now we can print all the utility for the first respondents, right? Right. So here you see all the utility score for all the attribute levels for the first respondents. Now, can you challenge yourself and replicate the code for the second respondents? Right here, we again use the function CA model, right? We want to build a regression model for the second respondent. And again, we need Y and X. Okay, so what is Y, everyone? You need to read the instruction, right? Y is vector preferences. In particular, right here, we need the second row of the DF dataset, the rating data from the second respondent. And we can specify here DF2, the second row. And of course, we need the profile of the attributes. Okay. Here's the regression result for the second respondent. And you see it's different compared to the result for the first respondent. So for the second respondent, there are three attribute levels are important to them. And again, we can see the plot of the utility score for the second respondent. All right, so we can use the function called CA utilities. And we need Y, X, and Z. Z again, if you have no idea what Z is, you can question mark the function and read the instruction, right? Z is the level, the attribute level data, and we call it the attribute level, right? So right here, we already print all the utility score for all the attribute levels for the second respondents. But if you cannot see the utility plot for the second respondent, it means sometimes the plot just hidden, underneath of the RStudio window. I will show you how to solve this problem, okay? So basically, you can minimize the RStudio window, right? And right here, you will see the utilities plot for the second respondents. Okay, so in particular, the first level of the life expectancy is important. The second respondent, they dislike the low life expectancy of the product, right? You see, this is negative value, and it is significant at 0.1 level, which is not a so strong effect. And for the second level of life expectancy, it is significant at 0.05 level, which is this one. It means that this person really like the medium life expectancy attribute of the product, right? And we also have the first level of the speed is significant at 0.1 level, which is this one. So it means this person also like the first level of the speed, which is the low speed, 1.0, right? All right, so let's come back to the RStudio, right? We just run the control analysis for every single respondents, but sometimes you want to run the control analysis for all respondents at one shot, in particular in the case that you have a lot of data from respondents, like 500 people, like 1,000 respondents. And in that case, we need to use a package called Conjoint, and you can question mark the function of this package. So right here is the usage and all the instructions. We need Y, X, and Z again, okay? So what do you think we will fill in this blank right here for Y? So this time we need all the data from the respondent, right? So that is the TF. We also need the attribute data, which is profile. And we also need the level data, which is attributes level. And let's run the model. And you see when we run the control analysis for all respondents, the effect is very strong, right? You can see like here and right here. Now, we would like to create a table of the utility score for all attribute level for all respondents. Okay, and in this case, we will use a function called CA part utilities. We can question mark the function to read the instruction. So we need Y, X, and Z. Okay, let's run the code. Right. Now you see that we just created a table with all the respondent in the first column, and we have all the utility score for each attribute level. Right. All right. So we just see the table, which is useful for sure, but we would like to know among the four attributes, which one is the most important one, right? And in this case, we use a new function called CA importance. We can question mark the functions and read the instructions. Okay. And in particular, we need Y and X. So what we should specify for Y? Y is all the data from respondent. I mean, the rating data, which is TF. And we need the profile of all the attributes, which is profile dataset, right? And let's run the code. So here's the result. What do you think? Which is the most important attribute? If you don't remember the order of the column of the attribute dataset, you can click on this one and you see. So the largest percentage is 37.67, which represent for the speed attribute. So it means that the speed is the most important attribute for all respondents. Right, and I would like to show you how to plot the data we just figure out, and we can justify things like more visually, right? Let's first plot the attribute's importance where we just calculated the percentage score here. Okay, so in this step, I will create a new data frame with two columns. The first column I call it attributes, where I extract the column names of the profile dataset. The second column, I will get the percentage score from here, from in variables. Let's run the code. Now I will create a bar plot using ggplot2. Okay. So right here, I will get the data from importance df, right? I just created. And then I'd reorder the importance score. I choose the color for each bar is the sky blue color, right? And I want to add a point that show the data for each attribute. Right here, I want to write the specific important values. For instance, like 35.91 for each importance point. Right here, I want flipped the coordinate to make it more readable. And right here, I want to add the title for the plot, the labels for X and Y, right? And right here, I want to use a very minimal background. And last but not least, I want the title in the center of the plot. Okay. Right, so let's run the code. So again, if you don't see the plot, the reason is sometimes the plot is underneath of the RStudio window. So here's the plot. So we have very beautiful plot, right? So you see, look at this plot, we see the speed is the most important attributes with 37.67% score. Right. Now, I want to show you another plot. Remember, we have the utility score for all the attribute level for all the respondents. That table is very useful for sure, but I would like to have very quick and powerful analysis of that data by creating a new heat map using ggplot2 package. And to create a heat map, we need to have some adjustment for the dataset. In particular, in heat map, only the long format data possible. What does it mean? So remember, we have the utility score, this one, in the previous analysis. Okay, so we have this table on the utility score for all the respondents. This data is currently in the Y format. What is Y format? So the Y format means each respondent is a single row and each attribute level is a separate column, right? Each respondent is a row, each column is attribute levels. And we would like to convert this dataset to the long format where each row will represent a single pair of respondents and attributes, and the long format is useful for the heat maps. Now, let's run the code and convert the current utility score dataset to the long format. That's it. And when I convert from wide format to the long format, I would like to make sure that the utility score is a number and the attributes is factor. Now let's view the long one. So you see now each row is a pair of respondents and the attribute, for instance, right here, respondent 1 attribute low with the utility score, still respondent 1 with medium attribute level and the utility score, and so on. Right? And here we will create a heat map, very similar to the bar plot. Right here, we would like to color the utility score to create a heat map. I give you some explanation right here. Try to read all the instruction right here and play with the plot by yourself. So we have very beautiful plots, right? And I also provide you some interpretation right here. Let's have a quick look. Right, so on the x-axis, we have all the attribute levels. On the y-axis, we have the respondents from 1 to 20. And we color the utility score for each respondent for each attribute level. And if you see something very red, it means that attribute is really liked by the respondents. If you see something very blue or purple right here, it means that that attribute level is not liked by respondent that much, right? So as a marketing manager, you need to figure out what is your offering space strategy. So if you look at the patterns of the whole group, you will see this red column is quite preferred by the respondents, right? And the same for this column as well. And the same for this column as well. But the question is, what is the marketing insights? You need to think, analyze, and design the strategy for yourself. So for instance, right here, you see the price had 3 levels, but customer might prefer the reasonable price only, right? And right here, the life expectancy had 3 levels. The customer want to combine that reasonable price with medium term of the life expectancy. So try to think and analyze the strategy for yourself.